Hello, and welcome to another lesson from Level Up Mathematics. In today's lesson, we will be exploring slope-intercept form of a line, part 1. In example 1, it says create a table and graph for the equation y equals 1/2 x plus 3, and then answer the questions. So in part A, they've given us a table with some x values, 0, 2, 4, 6, 8, and they want you to evaluate the algebraic expression 1/2 x plus 3 for each value of x to find its corresponding y value. So what we're going to do here to begin with is we're going to take this expression and replace the x with parentheses, and we'll do that for each line of our table. 1/2 parenthesis plus 3, 1/2 parenthesis plus 3, 1/2 parenthesis plus 3. Now let me grab a different color. So when x is 0, what we want to know is what is the value of y. So if I plug a 0 in here, 1/2 of 0 is 0, and 0 plus 3 is 3. So the value of y would be 3. So when I'm going to come over to the graph, when x is 0, y is 3. And we'll plot that point right there on the graph. All right. All right, what about when the x value is 2? Let's put a 2 right here. Okay. So 1/2 of 2 is 1, and 1 plus 3 is 4. So when x is 2, y is 4. So come over to your graph and go over to x is 2 and y is 4 and plot that point on the graph. All right, the next x value we want to evaluate for is x equals 4. So 1/2 of 4 is 2, and 2 plus 3 is 5. So we have a ordered pair at 4, 5. Let's plot that point right here on the graph. Over 4 and up 5. All right, our next x value is 6. 1/2 of 6 is 3, and 3 plus 3 is 6. So I have a point at 6, 6. And the last value of x they want you to evaluate for is x equals 8. So 1/2 of 8 is 4. 4 plus 3 gives me 7. So that means I have an ordered pair at 8, 7. Now notice that this expression, when graphed, formed a straight line. So let me kind of draw this in here. Kind of straight. And we could keep that going if we had more x values. All right. Now, in part C, it says, what is the slope of this line? And where do we see the slope in the equation? Well, we find the slope by finding the change in y, that's delta y, over the change in x, delta x. So let's use a right triangle here. If I started at my original point and went up and over to form a right triangle, notice that my change in y would only be 1 unit, but my change in x would be 2 units. Therefore, the slope of this linear relationship is 1/2. Now, we can also see that slope inside the equation. Let me highlight it for you. It's right here attached to the x. So the way we say that mathematically is we would say that it is the coefficient of x. It's the coefficient of x. That's our slope. All right. Question D. At what y-coordinate does the line intersect the y-axis, also known as the y-intercept? And then where do you see the y-intercept in this equation? So look at your red line here in the graph and find out where it touches the y-axis. Now, let me highlight the y-axis for you, just in case you've forgotten. This is the y-axis. It's our vertical axis. And notice that line touches the y-axis at the point 0, 3. So that's our y-intercept. Now, looking back at your equation, where do you see the y-intercept inside the equation? And notice we see it out here to the side. It's the value without an x. It's the value without a variable. And the way we say that mathematically is it is the constant term. The constant term. That's a fancy way for saying it doesn't have a variable. It is the constant term. Okay? Now, all of this leads us to a very important form of a line that you're going to be using in pretty much every math class you take from this day forward. And that equation is right here, y equals mx plus b. This form is called the slope-intercept form. So in this form, m is attached to the x. That means m is the slope of the line. Now, don't get me started on why they chose m to represent the slope. I'm really not sure. Okay? The b value is the value without a variable, and it's known as the y-intercept. So when you're given an equation on a homework assignment or a math test or really anywhere, and it's written in this form, you can immediately identify two things about the graph. All right, you can figure out what the slope of that graph is, and you can figure out where that line will touch the y-axis. So let's look at example 2. Identify the slope and y-intercept for each equation shown below. So in problem A, we have y equals 3x minus 7. And the first thing they want to know is, what is the slope? So to find the slope, we need to find the number attached to x. So in this case, it would be a 3. Now, do not include the x. The slope is just the coefficient of x, just the number that's attached to the x. All right? Now, your y-intercept is going to be the number that doesn't have a variable, the constant term. So in this problem, we know this line touches the y-axis at 0, -7. 0, -7. All right, problem B. Y equals 5 minus 2x. Now, what I want you to notice here is this equation is written a little bit backwards. If it helps you, you can rewrite it like this and put the -2x first and then the +5. It may be easier for you to identify the slope if it's written like that. So our slope is our coefficient of x, which is -2, and our y-intercept is the constant term, 0, 5. All right, problem C. We have another equation written in slope-intercept form. Y equals -x plus 8. So our coefficient of x here is the number that's attached to the x, and in this problem that would be -1. And our y-intercept, 0, 8. All right, problem D. Y equals 2/3 x. Now, on this problem, there's no constant term, but we can add one by putting +0 if we want to. So our slope, -2/3, and our y-intercept would be 0, 0. All right, now in example 3, this time I'm going to give you a graph, and you're going to identify the slope and the y-intercept in the equation. So remember, the equation form we're using is y equals mx plus b. So to put it to write the equation for a line, we need to know what the slope is and what the y-intercept is. Now let's start with the slope. Remember, to get slope, we want to find the change in y over the change in x. So let me write that down. Change in y over the change in x. And so I want to pick two friendly points. So maybe I'll use this point, and it really doesn't matter. We've got a lot of friendly points here. So I'll just use this one right here. Okay. Now to get the slope, I start with the bottom point that I chose, and we want to know, how did the y values change? Well, the y values went from 16 to 20. That means they went up 4 units. All right. Then I'm going to move to the left 1 unit. So that would be -1. So therefore, that tells me I have a slope of -4. Now, the y-intercept is where the line intersects the y-axis. So you can clearly see that it intersected the y-axis at 0, 20. Now we're going to put those two numbers together to write an equation. So y equals something x plus something. So remember, the slope is attached to x. So I'll put a -4 there. And then the y-intercept is your constant term. So your equation is y equals -4x plus 20. All right, let's look at problem B. Now, in this line, we want to first identify two friendly points. To me, I like to use the intercepts, so I'm going to use this point right here where it touches the y, and then I'll use this point where it touches the x to get the slope. All right, so to get the slope, always start with your bottom point, and then you're going to find the change in y. So this went up 1, 2, 3, 4, 5, 6. So the change in y is 6. And then the change in x. So how many did it go over? 1, 2, 3, 4. Now, those numbers will reduce. We can divide them both by 2. So if I divide them both by 2, I'm going to get a slope of 3 over 2. Now, the y-intercept, remember, is where does that line touch the y-axis? So I'll just count 1, 2, 3, 4, 5. So it touches the y-axis at 0, 6. So I'm going to put those together to write an equation to represent this line. Y equals 3 over 2x plus 6. All right, pause the video and try problem C on your own. All right, welcome back. Let's see how you did. I started off by choosing two friendly points. Then I connected those points with a right triangle to get my slope. And so this line went up 1, 2, 3. So my change in y was 3. And it went left 4. So my slope, -3 fourths. The y-intercept of this line was right here at 1, 2, 3. So 0, 3. So my equation was y equals -3 over 4x plus 3. Now, in example 3, we use the slope and y-intercept to write the equations of the lines. So I want you to pause the video and try problem A and B in the next example on your own. All right, welcome back. Let's see how you did on problem C. I used the intercepts as my two friendly points. So my line was going up 2 and over 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, and over 7. So the slope was 2 over 7. The y-intercept of this line was 0, -2. And I put those together to get y equals 2 over 7x minus 2. Check your answer with mine and correct anything that you got wrong. All right, let's see how you did on problem B. I used the two friendly points here and here for my slope. 1, 2, 3. Change in y was up 3. Change in x, 1, 2, 3, 4, 5, 6 was left 6. And that reduced to -1/2 if I divide them both by 3. Now the y-intercept, where did it touch the y-axis? Right there. So 1, 2, 3. So 0, 3. And then I put that together as y equals -1/2 x plus 3. Now, let's look at a couple real-world examples here. Example 3. The graph shows the relationship between the number of gallons of fuel remaining in the tank of a semi-truck and the number of miles traveled by the semi-truck. So let's look a little bit about this graph. On the x-axis, we're plotting the number of miles traveled, and we want to identify what the graph is scaled by. So it looks like this is 50, 100, 150, 200, and so on. And then on the y-axis, we have the gallons of fuel remaining, and it's being scaled by 30s. It's being scaled by 30s. All right. So the first thing they want to know is, what is the y-intercept in this equation, and what is its meaning? So I'm going to put a point because it's not on here. Grab a different color. Here is the y-intercept of this line, and it is at 0,240. Now, remember, the y-axis, we've plotted the number of gallons remaining. So if our point is 0,240, that means the 240 represents the original number of gallons in the tank when the truck, after the truck fueled up. So let's see, how do I want to say this? I can say the amount of fuel in the tank before driving any miles. Now, there's lots of different ways that you can express that idea. And so just in your own words, when you answer problems like this on your homework assignment, you're just going to answer it in your own words. But as long as you have the idea that it was the original amount of fuel in the tank, you're good as far as an answer. All right. Problem B. What is the slope and what is its meaning in this context? So to find the slope, I need to find two friendly points. So let's see. I only see one other friendly point, maybe right here. All right. So I want to get the change in y over the change in x. So if I connect these with the right triangle, do you see that I'm going up 30 units? Okay. Then I'm going to the left 300 units. 300 units. And if you reduce that, that will reduce to negative 1/10. So that means the fuel is decreasing because it's negative at a rate of 1/10 gallon per mile. The fuel is decreasing at a rate of 1/10 gallon per mile. Now, I'm going to put those two numbers together to write an equation. So y equals something x plus something. So my slope was negative 1/10, and my y-intercept was 240. So that would be an equation to represent this situation. All right, let's look at problem 4. The graph shows the relationship between the total cost to go to an arcade that charges an entrance fee plus an additional amount per game. So we can see that on our x-axis, we're plotting the number of games, and it's going by ones, 1, 2, 3, 4, and on. Okay. The y-axis, we're plotting the total cost, and it's being scaled by 3. So $3, $6, $9, $12, and on and on. Okay. So the first question is, what is the y-intercept? Well, here's our y-intercept. Let me draw that in. So 0, 12. So what does that mean in this context? Well, this is the point, 0, 12. So that means if you've played 0 games, your cost is $12. So this would be the entrance fee. It's how much you paid to get in before you've played any games at all. It's the entrance fee into the arcade. Okay. Now B, what is the slope and what is its meaning in this context? So I need to pick another friendly point. I've got one friendly point. How about if we use this one right here? So I want the change in y over the change in x. So I'm going from 12 up to 15. That's 3 units. Then I'm going over 1, 2, 3, 4. 3/4. Now, because this is money, we usually write money in decimal form. So this would be 0.75. The decimal equivalent for 3/4 is 0.75. So what that means is the cost for each game, so this would be each game costs 75 cents. Now, to put this together in an equation, we're going to have y equals something x plus something. So our slope was 0.75 and our y-intercept was 12. So the equation to represent this situation is y equals 0.75x plus 12. And that concludes today's lesson, Slope Intercept Form of a Line, Part 1.